Welcome to Module 4, Advanced Hunting using KQL. KQL, or Kusto Query Language, is the query language used to perform analysis on data to create analytics, workbooks, and perform hunting in Microsoft Sentinel and Microsoft Defender XDR. Understanding how to summarize and visualize data with a KQL statement provides a foundation to build efficient threat detections. As a security operations analyst or threat hunter, you will have to use a search language. In Microsoft, we use Kusto Query Language. You can query log data using KQL. The data is aggregated and correlated for you, and this allows for pattern detection. One such aggregation might be the number of failed logons. This information, combined with a predetermined threshold, can be used to generate an alert for a count with over 10 failed logons in the past hour, as an example. The KQL summarize operator performs the calculations. To quickly see a pattern, an analyst can visualize the results in a graph. The KQL render operator performs the visualization. Combining the summarize and render operators provides a foundation for advanced visualizations, including time bucketing and time slicing. Use the summarize operator. The count operator with its variations creates a new column with the calculated result for the specific fields. The first statement below returns one column that is a unique list of activity column values. The second statement returns a count of every security event rows where event ID equals 4618, and the count is grouped by process and computer. Because of the by clause, the results set contains three columns: process, computer, and count. Run each query separately to see the results. Okay, so we're inside Microsoft Sentinel right now. And as we can see, we come to logs. That's where the logs are. And where are we getting that information from? Here's, you can select a table and you can start running events. When you're inside Microsoft Sentinel, remember to come here and just click over here to KQL mode, and then you can start running your queries. So the first query that we wanted to run was the security event where event ID equals that. So we're searching for created scheduled tasks. So where do we get all the documentation for it? Well, we can easily come to the Microsoft documentation. So you can just Google KQL documentation. And we have the entire overview and plus the documentation all richly given to us by Microsoft. And you can go ahead and you can plug in all the gaps with what you need to understand here. So here simply we've got our Sentinel logs, and let's look for created scheduled tasks. So one of the most useful things that you can do for your own lab environment is set up a VM that's sending logs to your Sentinel workspace, and then what you do is you perform tasks on the VM and you let the logs go to the Sentinel or Microsoft Defender, and there you get your proof of concept. So here we're searching for scheduled tasks. So I'm actually going to schedule a task here inside this VM, and I'm going to schedule it to run a small script that checks my website. So here I'm going to create a task. Okay, inside create task, I can just call it web check. Okay, which is what it is. In description, it's a web check. And we can run only when it's logged on, that's fine. There's triggers, you can hit certain triggers. So you can make a new trigger, you can call it a time period or whatever. You can just call it one time, that's fine. You can repeat task daily, that's okay. And actions, we'd like it to trigger a script, program a script. Browse, I'm going to choose the script from my desktop. It's called website check. Website check, there it is. Click OK. Click OK. Now I've created a scheduled task. Now what I can do is, so these things take time for the stuff to get sent to Microsoft Sentinel. That in any event, I've created a scheduled task, and I can go ahead and I can go hunt for the scheduled task inside Microsoft Sentinel. So let's go ahead and do that. So I go ahead and I type the query. You guys have access to the query and you're going to have access to the cheat sheets also. And we can see I'm querying the security event table. And let's go ahead and let's run it. Let's just set time range, set in query. Okay, well, the time range is set in a query. So time generated to go 7 days ago. Let's not do that. Let's say in the past 24 hours. We can take this time generated 7 days ago out because that's not the time that we're looking for. And we can go ahead and we can run that. And it might take some time, might take a few minutes for these logs to be sent to Sentinel. But in essence, that's going to search for the scheduled tasks and a created scheduled task. So let's get back into our notes. So that was to search for created scheduled tasks. Scheduled tasks is a common way that attackers use to maintain persistence. So we're creating the security event table where event ID is 4688. Where new process name contains a scheduled task.exe, etc., etc. Bear in mind that we were using, if you're using sys1, this will be different. That virtual machine of mine was using sys1. It's not running sys1 anymore, but it should work quite nicely. Just remember whether you're using sys1 or Windows event IDs. So we can search for malicious documents with macros connecting to a suspicious domain. So here again, we're searching the security event table where event ID equals that. And here we're looking for a new process name in WinWord, Excel, or PowerPoint, where not command line contains Microsoft.com or command line contains live.com. So we whitelisting those Microsoft URLs, or command line contains Office.com. We want to project time generated computer account command line and new process domain, new process name. So once again, what you can do, you can actually create a new query. I can create a new query here. Remember, simple mode into KQL mode. And I can go ahead and I can copy and paste. KQL mode is my default. I can go ahead and I can copy and paste this entire command. And I can go ahead and I can run. And that will search for any malicious document connecting to a domain. That does not include Microsoft.com, because remember, this can be a false positive for you. If you're running this query and you see that WinWord, for example, is connected to Microsoft.com or Live.com or Office.com, you know that it is not malicious, it's benign, it's just a false positive. If it's because it's probably OneDrive. If it's something else, then you know that you're dealing with a malicious document. Okay, connecting to a suspicious domain. Okay, here we search for partial execution events that could involve a download. So security event where event ID equals 4688. A new process name contains partial.exe and the command line has any web client download file, HTTP, HTTPS, and project time generated computer account command line and new process name. Let's go ahead and search for this. So we can create a new query. Interestingly, this is what there was actually partial commands that this was an alert that was generated on my system, but I'm going to call it, we can call it, say, the last 7 days custom. If we do custom, we can go from, say, October the 1st to November now. It's going to take, the longer you set the time period, the longer the query is going to take. It doesn't contain any event, but I did in fact see this event in Microsoft Defender for advanced hunting, so we'll go there after we've done this. As we've been through before, we're going to search for a program attempting to dump alsas.exe. So that security event where event ID is 4656 is to handle to process requested, where object name contains alsas.exe, where process command line contains db core or process command line contains dbg help, and we're going to then project what we need to do. Okay, so since I did perform alsas dumping, the problem is that this is in the table. It's actually configured for sys1 events. Like if I just double click events and I run event in the last 24 hours, let's just say the last 48 hours. It's not 7 days. These things can take time. Remember that we're working with a virtual machine here. So this is all sys1 events. I don't want sys1 events to be running anymore. If you want to convert it, what you can just do is you can say convert Microsoft event ID 4688 to equivalent in sysmon. Equivalent in sysmon. Okay, for some reason it's giving me a different language, but 4688 is a new process creation, so it's process creation event ID in sysmon. Okay, we can go for that. It's event ID 1 for process creation. So we can just go back here. We can add a new query. We can paste our query here, simple mode, KQL mode. So this is how you're going to have to convert this stuff. So we're event ID here, we're just calling it 1 because it's a sysmon event ID. It's 1. So we're just going to go ahead and we're going to run that query. We can run it over the last 7 days, and we can just hit enter to run for cancel. Okay, it's giving us an error that we have to debug, but essentially this should work. It's just 4656 run. Okay, you're going to have to be able to do a little bit of debugging, but that was not 4656. That was sorry, that was 4656. So Windows event ID 4656. Okay, so you're going to have to know your logs pretty well to do this. Handle an object that was requested. Interview sysmon equivalent. Okay, that's Windows event ID. Handle an object was requested. Sysmon event ID. Need to handle when object was requested. For some reason, sysmon isn't working too well with this. So it's sysmon event ID 7. Is image loaded? We can do that. We can say image loaded. So we can actually change that query to event ID of 7. And this is how you're going to debug and perform these operations. So line 3, position 40, it's a request ID, and it says the query could not be passed. You might have to do some troubleshooting. And if it's not working for you in Sentinel, just jump over into Defender. Let's get back into our notes. So that was searching for an LSAS dump. There are many ways to do it. So here we can search for malicious documents with macros connecting to suspicious domains. So security event, where event ID is that, where file name is that, where not command line contains, obviously we're working out the Microsoft stuff. And then you're going to go ahead and project that. So let's go ahead and do it. Okay, we come here, remember simple mode, KQL mode, run your query, and then search. And it also says it could not be passed. You might have to troubleshoot and change a couple of things. We're using the security event table, so you have to look at the account names, file names, and then you have to get the equivalent. So if I go to security event table here, it's under Microsoft Sentinel, security event, I have to look for the equivalents for those queries, so for the column. And you'll find it's not account name or something else. Account type, account session, account name. So it's account name without the S. Okay, and we can see that that's already, this is how you debug file name. So let's go back here. Let's go to Microsoft Sentinel security event. Let's look for the file tables. Go all the way down to F, file hash, file path, filter. So it has no file name, file path, no user, filter, file name. So we can actually remove that out of there completely. We don't need to be protecting that if it doesn't contain anything. Okay, so where file name in WinWord contains or that, where file name. So what is the equivalent? We have to look for it inside there. So we have file name. So you're going to have to look for something different. You can put a file hash, fully qualified domain name, which is good. Target info, I can't find it right now. But essentially, you're going to have to be doing debugging according to that. And you can just do Control Z there, file name. In contains that. So this is not working. We can't find file name. So what we do is we just come to the Microsoft documentation and we see that file name does exist in device file events, but it's in Microsoft Defender. So we would want to jump over to Defender for this. And we'd want to go ahead and we'd want to run the query in Defender. New query. Add a new query. Take this away. So here's for advanced hunting in Defender. We can see that device process events is going to work because we have the column file name, etc., etc. So we can just go ahead and we can run the query. We run it over the last 7 days. And basically there are no results that were found. So remember, jumping in between Sentinel and Defender Advanced Hunting will be helpful for you. Okay, search for malicious document that executed another program. This can be also very useful. So here we're searching the security event table again, and let's go ahead and run the query. So I can just add a new query here, simple mode to KQL mode. Control V, and we can see again that the file names are different. So this query should run better inside Microsoft Defender just because security event doesn't have file names. So we can go ahead and we can jump over into Defender. So we can modify this for Defender. And we can see that there we can run the query. So once again, jumping between Advanced Hunting and Defender and Microsoft Sentinel. So also what we want to do is we want to search for domains contacted by a process name or PID. You can let the process ID equal the PID. This may be useful in combination with memory forensics. And we're initiating process ID is the process ID. So you're searching for a process that's connected to a domain. And you can go ahead and you can just paste this inside Microsoft Sentinel. So we can just use Advanced Hunting for Defender. So we've changed, let's say, for example, the PID equals 4. So say, for example, you're working with the memory forensics team and you had to troubleshoot that just to show you my steps here. So I pasted the query in, and obviously PID isn't PID, it's not what it's looking for a number. So I can go ahead and I can run that query, and that will bring you back the results that you're looking for. You can see there's, actually we do have some results here. So this is where so the processes that were contacted by specific PID. So here we have the actual desktop or the actual system that was involved, and we can just drill down on that and we can see all the details. So the initiating process was 4, and we can see the whole process tree. We can see the assets that were involved. And if we just go ahead and just scroll down here, we can see the timestamp and everything. And we can see where the this PID connected with a domain. So TCP4, and we can see exactly what PID it was. So that's search for domains contacted by process name or PID. So you can search for processes executed based on hash, name, or path. Right. Now, as we were looking in threat intelligence in the previous day, there were some indicators of compromise, and there are some file hashes that you can be looking at. Let's go back and let's choose an actual one. So here we've got an analyst report for these are indicators of compromise from a specific attack. So for example, here's a SHA-256 hash, and I can copy that. Go ahead and copy that. So here we have it. We put this malicious hash inside here. We can go ahead and run it. Over the last 24 hours, and there's nothing. But if that indicator of compromise from that specific attack was part of this, you could go ahead and search for that. So this is again, once again, just teaching you how to utilize your cyber threat intelligence. So here's cyber threat intelligence. You could work all these hashes into part of alerts and queries, and as part of your threat hunting. So we've been through that. Query by file path, this is basically the same thing. To find commands executed on the system, you find command lines. So you're searching for all commands, right? So this again, this is where event ID equals 4688. And let's go ahead and but remember we're working with sysmon, so we have a different event ID. And let's go ahead and let's just run this query. So as we can see, this query is not running nicely on inside Sentinel, so what we'll do is we'll jump over into Advanced Hunting and Defender. So inside Advanced Hunting and Defender again, we're going to go ahead and we can add this because we're looking at the device tables, device security events. And there we can go ahead and we can query. So what it's done is it's brought back all the commands. So here's a command that was run here. So it's command, it was using QC npcap, and the file name was command.exe, and it actually gives you the folder path. So this is a very useful query for looking at all of these things. And you see sometimes you have to debug inside, you have to search. Sometimes it's not the exact table or column name, and then what you do is you find it, and then you go ahead and you run your query. Okay, that's to find commands executed on the system. So list all processes executed by a malicious program. Yeah, so we can see that this is going to create we're going to need to do quite a lot of debugging. Inside security event table, we might want to jump over into Microsoft Advanced Hunting and Defender, and we can do that. So we've done a little debugging, and we can go ahead and we can run the query. And if there's anything that will be brought back, nothing's been brought back. You can list all domains that resolve to a specific IP. So let given IP, you can put your IP address in there, and then you query Azure Network Analytics and where remote IPs, and then you project what your remote IP is, your remote URLs, initiating process, file name, command line, etc., etc. Find processes created by a specific user. Here you just let the username equal username, security event, where count username, and you go ahead and project what you want. Find dropped or downloaded script files. Okay, this is quite an interesting one. So we're looking for event ID 4663. It's a file creation modification event. And then we're going to have to do a little debugging, but let's go ahead and get it done. So we're going to have to do some modification here. So this is initiating process account name. Okay, parent process name is initiating process account name. There's no parent process name here, so we can just take that out. And remember that this is process command line. Or initiating process command line. You can just go all the way down, choose initiating process command line, and now we can go ahead and run our query. And see if anything's brought back. Yes, it's brought back quite a lot. So this is device file offense. This is where files being created. And we're looking for possible downloaded scripts, and we can see there's a lot. We can drill down on this. Here's a PowerShell script that was run, and we can see the initial everything basically behind it, the file name, and exactly what went down there. We can take a look. We can see that machine that's infected, the initiating process account name, initiating process command line was PowerShell.exe. There's the file name, so it's a PowerShell script, and there's the folder path. So that's to look for dropped scripts. And here we can look for detecting the mounting of the ISO or .img or .image events. So we're looking in the security event table once again, and we're looking where the file name ends with ISO link or file name ends with image link. We're going to project the computer accounts, print, process name, command line, file names, etc. So this is quite an advanced query that requires quite a lot of debugging inside Microsoft Sentinel and Microsoft Azure. So I challenge you to try and debug this on your own. And I really enjoyed this session, and I hope that you look forward to seeing me on the next one. We will be focusing purely on advanced hunting in Defender.